So for our final video in this unit, we're going to start looking at parallel and perpendicular lines. So you should be able to identify parallel and perpendicular lines just based off of their equations, and then be able to write actual linear equations by, if I say make a line parallel to this graph, you can write the equation to that. So let's review a couple things. I want to review point-slope form and writing it in slope-intercept form. So for this review here, point-slope form, remember, is just y minus y1 is equal to, that kind of looks like a 4. Hold on, I don't like that. Let me just start over. Okay, so y minus y1 is equal to m times x minus x1. So they give me plenty of information to work with that. They give me the -1 and the 5, and then they give me the slope of -7/16, which is a fraction. That's okay. So a friendly reminder, this is x1 and y1, and we'll just substitute in our known values. So I would have then y minus 5 is equal to my -7/16 slope times x, and it would be plus 1 just because it's a -1. And remember, minus and negative turns to plus. And they don't ask me to change this to slope-intercept form. They just say, what is the point-slope form of this? So I'm actually going to just stop here. I can leave it here. Okay, so that would be my final answer. So we do have some vocabulary terms. So parallel lines are lines, obviously, that never intersect. And so a symbol for parallel lines would just be this, okay? They're parallel. Or if I'm in geometry, I would say, line A is parallel to line B. And an example of that on a graph could look something like this. So they're never going to intersect. Now, let's just take a minute and maybe just kind of briefly analyze that graph that I drew. Obviously, it's not perfect, but if I'm telling you those are parallel, they're never going to hit each other. So that means they have to, this is important, they must have the same slope. Which would make sense, right? They're rising and running at the same rate, so that means they'll never kind of like almost in a way catch up with one another. And then perpendicular lines are lines that will intersect. So they are lines that intersect and form 4 right angles. And a symbol for perpendicular kind of looks like an upside down T. And an example of that might be, let's do this. Let's say I have a line here. Perpendicular to that will look something like this. Now, what's important to know about their slopes, obviously they're not the same. So we call slopes of perpendicular lines opposite reciprocals. So like I think of it like they're opposite in all ways. So for an example of that, let's say I had the slope of a line was -2/5, right? So perpendicular to that would not only would it be positive, but then I would flip it around and make it 5/2. Or let's say I had a whole number. Let's say I had a slope of 4. Well, the opposite reciprocal of that would be now negative. And the reciprocal of 4 is 1/4. So we can use that information to identify parallel and perpendicular lines as well as write equations. So the first thing is, let's just identify what we have. So in order to identify slopes of an equation, that means I have to have it in slope-intercept form. Okay, so I'd probably write this down. So must, and actually, hold on, let's cross that out. I'm going to put equations must be in slope-intercept form in order to compare slopes, right? I need to be able to pull out the slope. So my first example, my first equation is not in slope-intercept form, and so what I would do is I would go ahead and subtract 3x over. And I have now the equation y equals negative 3x then plus 12. So this is no longer my equation at the top. So to avoid confusion, I'll cross it out. Now I'm going to look at my two slopes here. I don't care about the y-intercepts. I have negative 3 and 1/3. That is opposite reciprocal, right? So because this is the opposite reciprocal, that means I have perpendicular lines here. Looking at example B, again, my first equation is not in slope-intercept form. And I'm actually going to zoom up on this guy. Let's see if it'll let me. There we go. So I'm going to begin by subtracting 4x to both sides. Subtracting 4x. Now I'm left with negative 3y is equal to negative 4x plus 12. I'll go ahead and divide everything by negative 3. So my negative 3 is now gone. I get y is equal to positive 4/3 x. So the negative divided by a negative. And I can't simplify 4 over 3. And then minus 4. So now I'm going to just look at, and it's really convenient that the other equation is in slope-intercept form. So I've got a slope of 4/3, slope of 4/3. Ooh, they're the same. So if they're the same, that means we have parallel lines. Looking at example C, why don't you guys try this one on your own? So you would have started with subtracting 8x to the other side, leaving you with 2y is equal to negative 8x plus 4, dividing everything by 2, and we get y is equal to negative 4x plus 2. Great, it's in slope-intercept form. So is the other equation. So I've got a slope of negative 1/4, and then also here I got negative 4. So they are the reciprocal, right? So 4 is the reciprocal of 1/4 and vice versa. However, they're both negative. Because of that, they are not parallel or perpendicular, so we say neither. It's kind of a tricky question. I kind of like it, so I'd star that one. And then I very much like example D, because notice how I'm only seeing one variable in each equation. So hopefully that's triggering in your brain, hey, ding, 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 Vux Hoy stuff. Okay, that looks like Vux Noi. Vux Hoy. So for the 5x equals 10, I don't necessarily have to get x by itself, but I guess I'm just OCD, so I'm going to do that. So it's really just x equals 2, and then I've got y equals 12. So here's the thing. I have to know and almost kind of visualize slopes of x equals and y equals, right? So x equals belongs to Vux, so I know this is an undefined slope, right? It is vertical. It's going up and down. Well, this belongs to Hoy, so this means I have a 0 slope, so it's going horizontal. So those are the epitome of perpendicular lines, I feel like. And so we would say perpendicular. Okay. So now we are also going to write equations that are parallel and perpendicular. So in example 2, it says write an equation in slope-intercept form. I'm going to underline that because it tells me what it wants. Okay, we got to read and pay attention to detail here. For a line that passes through this point and is parallel to this. So they're giving me this equation just so I can identify the slope, my desired slope. So my desired slope, if it wants to be parallel, we want it to be the same. So I'm going to use the slope 1/2. And this kind of reverts back to our first video, writing equations of lines giving a point and a slope. So I'm going to plug this into point slope form and then eventually manipulate that to slope intercept so I can graph it. So I'm going to use that given point, so I'd have y plus 2, because it's a negative, is equal to 1/2 times x minus 4. So I'll go ahead and distribute the 1/2, so I get still 1 plus 2 is equal to, y plus 2 is equal to 1/2 x minus 2, subtract 2 over, and my equation in slope-intercept form is y equals 1/2 x minus 4. So that's half of my answer, because then I'm also going to graph this line. So I'm going to, let's see. And just to show you guys, I'm actually going to just kind of go above and beyond here. I'm going to graph both equations. So I'm going to do that one in green. So let's see, we got -7. So that's where we start. Here we go. And I'll go up 1 and over 2. That's a great way to check our work if we just graph both of them. Alrighty. And then I'll graph my new equation that's in blue. I'll do that in blue. And I also have a slope of 2. What a beautiful sight there. You can tell that they're never going to intersect. So let's try the next example. It says write an equation in slope-intercept form. I'm going to underline that again. For a line that passes through this given point and is perpendicular, so we should be thinking opposite reciprocal slopes, of the graph 7x minus 2y equals 3. Okay, so a couple things about this problem. Not only do they want it to be perpendicular, but they give you an equation that's not in slope-intercept form. So I need to change this because I need to be able to pull out that slope, right? So I'm just going to write the problem down here, give myself some room. So I'm going to get y by itself. So I subtract the 7x over, which leaves me with -2y is equal to -7x plus 3. And then I'll go ahead and divide everything by -2. And I get y equals, okay, that's going to turn to +7 over 2x. And then minus, I'll just put this at 1.5. I don't really care about the y-intercept, right? The only information I need from this is the slope, okay? So if it's going to be perpendicular, then the slope I want to use is going to be -2 over 7. So now I have enough information to write this in point slope form. So I'll do y, and then because this is a -1, it'll be +1 is equal to -2/7 times x minus 7. I'll go ahead and distribute that 2/7 or the -2/7 to the x. And then when I multiply it by the -7, that gives me +2. So that worked out really nicely. Subtract 1, and so my final answer is y equals -2/7 x, plus 1. So let's graph both of these if it'll let me. Let's see here. So let's see, I'll graph the original equation here. I'm going to graph that in green. So it'll be kind of an estimation since my y-intercept's a -1/2. And I'll go up 7. So let's see, 1, 2, 3, 4, 5, 6, 7 over 2. And I'll go down 7. 1, 2, 3, 4, 5, 6, 7 over 2. And I can kind of get an idea. That was a terrible straight line, but you get the idea. And now I'll go ahead and graph this in red. So I start at 1, and I go down 2 over 1, 2, 3, 4, 5, 6, 7. I'll go up 2 over 1, 2, 3, 4, 5, 6, 7. And I've got a great set of perpendicular lines. So why don't you guys try the last one on your own? So write an equation in slope-intercept form for the line that passes through this point and is perpendicular to the given graph. Okay, so I would have started with taking that 5x plus 3y. Let's get that into slope-intercept form. I needed to identify the slope. That's all it's really good for right now. So I've got 3y is equal to -5x plus 3. Divide everything by 3. And so I get y is equal to -5/3 x plus 1, right? Okay, so I'm going to take that equation, and all I want is its slope. And we're working with perpendicular lines, so that means I need opposite reciprocals. So the slope that I'm going to use will be +3/5, right? And so now I can write this in point slope form. So I'm going to use y, and then I use my y value, which is 6. So it's -6 is equal to 3/5 times x minus 5. Let's get that into slope-intercept form. I distribute the 3/5. This works out real nicely of being -3 there. And then we'll add 6 to both sides. And so I get my final equation of y equals 3/5 x plus 3. And let's go ahead and graph just both the lines just to see that these are perpendicular. So, and it's great practice. So I'm going to start at +1 for the original. And I'm going to go down 5. 1, 2, 3, 4, 5 over 3. Or up 5 and to the left 3. There we go. And then I'll go ahead and graph my new equation that's in red here. So I'll start at 3. And I go up 3. over 1, 2, 3, 4, 5, or down 3, 1, 2, 3, over 5, and wha-bam, I've got my perpendicular lines.